For this lesson, we are going to be looking at the surface area of triangular prisms. So when we think about a triangular prism, it is a prism because it has two congruent bases, and it's a triangular prism because the two bases are triangles. In a prism, the lateral sides are always rectangles. So we have our two triangular bases. We have three rectangular lateral sides because it's a triangle, and a triangle has three sides. If we had a hexagon, we would have six sides, or six lateral sides, right? If we have a rectangular prism, it has four because a rectangle has four sides, okay? When we think about the surface area, we are going to find the area of these two triangle bases, and there's two of them, right? And then for these lateral sides, we have three base lengths that all have the same height. And these three base lengths are going to be the three sides of the triangle, because if we think about it on here, that's how they match up. Side 1 of the triangle, side 2 of this triangle, side 3 of the triangle. If we look at it this way, maybe a little easier to see. We have this side is the length of that rectangle, this side is the length of this rectangle, and this side is the length of that rectangle. So let's think about that here. For this first one, I'm going to draw out a little sketch of the triangular prism. The rest of them I am not, okay? So if I kind of think about this, I've got three lateral sides, 1, 2, 3. And then we have a triangular base. So looking at my triangle, okay, I have three sides here, okay? I have 6, 8, and this length, even though it's not listed there, if I look across over here, is 10. So we have our small rectangle is 6, our middle rectangle is 8, our large rectangle is 10. The other length that is given to us is the length connecting these two bases to each other. Our triangle in the front to the triangle in the back. That length of 15 is going to be the height of these rectangles. And then for our triangle base, okay, we want the base and height that meets at a 90-degree angle, which in this case is these two side lengths, 6 and 8. So for this triangle, the right angle gives you a base of 8, height of 6. Same thing up here, base of 8, height of 6. So now we should be able to go through and find the surface area of this triangle. For our lateral sides, I am doing, this triangle is 15 times 6, okay? This rectangle is 15 times 6. This rectangle is 15 times 8. And this rectangle is 15 times 10. So it's the three side lengths of the triangle times that same height. And I can calculate that. 15 times 6 is 90. 15 times 8 is 120. 15 times 10 is 150. Then for our bases, there's a couple ways that you can do it. I can think of it just as normal. I'm going to find the area of this base. For a triangle, it's our base of 8 times our height of 6 divided by 2. But we have two of those, so I'm multiplying that by 2. Which we can actually calculate it this way, or we can realize if I'm dividing by 2 and then I'm multiplying by 2, it kind of cancels out. So I'm really just doing 8 times 6, which is 48. But if you had plugged 8 times 6 divided by 2, which is 24 times 2, you'd also get 48. Now I'm just adding these all together. So 90 plus 120 plus 150 plus 48, and we get a surface area of 408 inches squared, because area is squared. Okay, let's look at the next one. So first I'm going to look at our three side lengths of the triangle. And I'm going to look at it on the bottom here because that's where I see most of the side lengths listed. So for our triangle, we have 6, 9, 12. So we are taking these three triangle side lengths. Those are going to be our 3 lateral sides. And we are multiplying it by the height that's connecting our 2 bases, that connects the triangle here and the triangle there, okay? So that height or length of 8 is going to be the height of all 3 of our lateral rectangle sides. So 6 times 8 is 48. 9 times 8 is 72. 12 times 8 is 96. And then for our base, we're looking at our triangle base here. So if I look at the top, because I don't see a 90-degree angle on the sides, if I look here on this top triangle, that's where I see this 90-degree. So it's showing me a height of 10, and it's connected to this side length, which if we look on the bottom is 6. So we're doing our base of 6 times our height of 10, divided by 2 to get one of the triangles, and then we multiply it by 2 because there's 2 triangles, which gives us a total of 60. And then we're just going to add this all together. 48 plus 72 plus 96 plus 60, and we get a total surface area of 276 meters squared. Let's try one more. Sometimes people look at this one and they get kind of confused, but again, if you can break it down the same way, you shouldn't have an issue. We've got our triangle side lengths, 1, 2, 3. Well, let's see what those side lengths are. We have 15 right here. For this side length, it's not written right there, but it's going to be the same as this bottom one, which is 13.2. So we have 15, we have 13.2, and the last triangle side length is right here, which is not listed, but if we look at the bottom, it's the same as this length here of 20. So those are our 3 lateral sides because it's the 3 sides of the triangle. Then the height that is connecting the 2 triangles together is this length right here. That 5 is connecting the bottom triangle to the top triangle. So all 3 of these lateral sides have a height of 5. So I'm multiplying 15 times 5 is 75. 13.2 times 5 is 66. And 20 times 5 is 100. Then for our base, I see the 90-degree symbol right here. That's connecting our side of 15 and our side of 13.2. So for our base, it's 15 times 13.2 divided by 2 to tell you one triangle, multiplying by 2 because there's 2 triangles, which is going to give you an area of 198. And now we add that all together. 75 plus 66 plus 100 plus 198 gives us 439 meters squared.